Hi, Julia. Welcome to the podcast.
Hi, thanks for having me here, Fabian.
No, thank you so much for joining me today. Before we talk about all things AI, let's learn a little bit more about yourself, if that's okay. You're currently the co-founder of Presada, a AI technology startup. What led you to founding this company, and what specifically do you do?
Oh, yeah, that's a very long story. So, to be very honest, when I left university or my university degrees, I could have never imagined starting my own company. But I think that's something which evolved over the time because when I saw what we can do with AI and with sensor data processing, ideas arise, and at some point really I wanted to push them forward and wanted to start my own thing, and that's how everything came together in Presada. And what we actually do is using sensor data to support people to enhance their communication skills. This sounds kind of odd at the beginning because yeah, communication is an interpersonal skill. Let's train that with AI. Well, we found out that especially people love to train on their own, but they need feedback, and that's what we can provide nowadays with AI models in real time. So why don't we use them? And that's how everything evolved.
Thank you so much for the context. This is, of course, the Gen AI Automotive podcast, and you've worked in automotive. Let's maybe briefly touch on it as well. What's been your relationship with automotive?
Where I come from is actually from robotics, so developing autonomous robotic systems. And I have been working in automotive and aviation in this field. And especially in automotive, I specialized on environmental perception. And as you can guess, sensor data processing, sensor data fusion with AI algorithms. Because, I mean, we know now for 12 years, probably more, that machine learning models are simply state of the art when it comes to sensor data processing, sensor data interpretation, getting environmental models for AI. And that's where I come from.
No, thank you so much. Everyone has heard about sensor data, and I guess there are some quite visual examples when we think about sensors around our vehicle, and some might know a little bit about sensors in a production environment. But just for someone who isn't so close to the topic, would you mind just giving a little bit of context to the different types of sensors and sensor data that you work with and or we as an industry work with?
Yeah, sure. So it actually heavily depends on the OEM and the strategies they take when it comes to environmental perception for automated driving, for autonomous driving. On the one hand, we have those companies who really set on the multi-model sensor data setup. Multi-model because we have different sensor types, which means we see there usually cameras, we see radars, we see ultrasonic and LiDAR sensors, so light detection and ranging sensors, um, which measure the distance to other objects with the time of flight. So we have very accurate distance sensor, measurements here. So on these different sensor types, what we see is a camera, very structured data. So we get our matrix, we get our image, we can work with the image as we know it from machine learning examples. But when we talk about radar and LiDAR, we get so-called point clouds. Point clouds are unsorted lists of measurements. So depending on which sensor and which sensor model you use, these lists can be shuffled, but still represent the same environment. So we need machine learning models which can operate on those lists as well, or some tricks to process them. For example, also projecting them to some kind of image-like representation. So these are the tricks how we can work with machine learning for those sensor types. And of course, on the other hand, we have OEMs which say, okay, we only drive with cameras. more or less. They turned back to using at least some kind of radar in addition for their automated driving, autonomous driving efforts. But what they claim is with this unimodel setup with the camera, so the single sensor type, we as human also have our vision and can work with it. And they say, okay, we have a sensor type which is giving us the same information. But in my opinion, what they lack is that we as human are extremely good in processing the data. And that's what we cannot yet achieve with machine learning models and with the computational power we put in a tiny car embedded system.
Super interesting. You kind of alluded to this already, but more specifically, what are some of the typical challenges that you see as it relates to different types of sensor data and how organizations unlock value from them?
Yeah, so we have multiple problems here. So especially for machine learning, what we need is we need testing and test kilometers, test hours to prove that the things are working. So since we have here statistical models in the back end, we need to prove over the hours and the kilometers that everything is working. So what we need there is a complete coverage of all the test scenarios, test cases you can imagine. And especially for corner cases like accidents, cut-ins, special weather conditions, it's super hard to get the data. So what we need is actually a broad distribution over sensor data also for those cases, which is really challenging to get. So number one problem, how to acquire the data. And I mean, we are talking about petabyte of data, especially when we record cameras, and how to organize and structure this huge amount of data. So this is one challenge on its own, and a lot of professions like data engineers, computer scientists, and so on and so forth, they are really looking into how to deal with the data. So on the other hand, of course, we have the machine learning model itself. So when we talk about nowadays of models like ChatGPT, I mean, we have billions of parameters inside there. So we cannot use those models on tiny embedded sensors. So what we need is really looking into models which are trained specifically for this use case and which then get pruned in a way and optimized in a way that we can really put them on embedded systems and also let them or deploy them in electrical cars. So no driver would want to have 100 kilometers less driving range just because an AI model is running in the trunk. So this is something we really need to take care of. And I think these are, amongst others, the two biggest challenges what we see when we apply machine learning here. Yeah, speaking of machine learning, I mean, still it's the Gen AI podcast in automotive, where I see the big benefit nowadays of really generative AI. Speaking of these two problems is, first of all, in the scenario and the data recording, what we can do is at least help with Gen AI with all this textual processing to support this use case generation. So if you take a look at automotive testing, you have your test catalogs, a lot of them written in human readable language. So we can use those models also to track the requirements, to track the use cases, to support the engineers there. On the other hand, when we talk about data, we see also models, the so-called nerve models, where we can support in transforming sensor data to other modalities or other view angles or special weather conditions. So for example, if we have a ride with a car with a specific sensor setup and we want to transform it, of course it's only possible to a certain extent, but we want to transform it to have the similar sensor data set up from a different viewpoint, for example, from a truck, we can support it with those models.
No, thank you so much for the context. On that last point, you alluded to the diversity and richness and accessibility in terms of data that's needed for lots of these highly specialized use cases, which leads me to the point of synthetic data, which we hear a lot about at the moment. How relevant is synthetic data for these types of automotive use cases that you alluded to, and what are some of the, I guess, associated ups and downsides or possible ups and downsides?
Yeah, when it comes to synthetic data, I think there is no way around it, especially for development. So when we are not talking really about the test cases, but within developments, engineers need fast, accessible data. And one way to test specific scenarios is definitely through simulation. So when we take a look at the processing pipeline, when it comes to automated or autonomous driving, in the beginning we have the sensor data processing, then we have some kind of reasoning, tracking, and then it comes to really the decision and the driving behavior. And especially for the later parts, when we already have some kind of abstracted information, simulation is totally fine, especially for development. It's a little bit trickier for explicitly the sensor data processing, because what we saw was that we get some kind of an idea what data we can expect from the sensors, but they are really far apart from the real sensor data what we get, especially in challenging conditions. When we talk about LiDAR, things where the side is distracted, for example, fog, heavy rain, heavy snow, where we have the reflections. And that's where it really gets challenging and interesting to get also more data. So that's where I see these nerve models with some kind of learned representation, sometimes even better as real physics simulations of the sensors. Because what we also saw is it's super hard to simulate those sensor models, especially when we talk about new sensors. So this field of LiDAR sensors is heavily developing. So previously they had this rotating mirror idea where either the diodes or the whole head was spinning, so that we can get the surrounding. And nowadays, this is switching back to solid state LiDARs, so that we get rid of these moving parts inside the sensor. So less moving parts, broader field of view. So we have some benefit, or some, we have a lot of benefits there, and get rid of all the disadvantages of the sensor modality. And especially when you work on this novel type of sensors, you don't have so much knowledge about the simulation yet. And then it can really help to get data and learn some kind of models outside.
One of the questions that is currently being discussed a lot and completely appreciated with your current company, you don't directly work in the automotive context. So a little bit more of a sort of speculative, creative question in a way. But one question that's being discussed a lot is what capability OEMs should internalize and where the technology for some of these use cases is coming from. What we see a lot at the moment is, first of all, some of the developments with the established technology companies that all push some form of Gen AI capability in their existing products, whether it's GitLab, Salesforce, AWS, GCP, all of them. And then we've got loads of specialized startups that focus on very sort of niche use cases that usually use one of these large language models from Meta, from OpenAI, from Microsoft, and so on, and then train them for specific use cases, provide a UI that organizations can use. And it's really convoluted and messy in a way at the moment. It's really hard for automotive companies to navigate. And as far as I'm aware, no one really has a sort of clear structure in terms of how to approach these problems. And I was just wondering if you've got any perspectives on the future of that and maybe some recommendations for automotive OEMs associated with that.
Yeah, that's a very good question. And I think it heavily depends on the company culture and how things are set up there. So, although I'm not working for a supplier anymore, I still have a lot of colleagues in this area and see how the field is evolving, especially international. So, on the one hand, we have companies who wants to do everything in-house. So, I mean, they are from the construction to the development of the software. I think the only thing they buy are sensors. So sometimes they even develop sensors on their own, and but especially software stack is on their own. They don't buy it, and that's super interesting because those are companies which don't have that long tradition into mechanical engineering and have or are this kind of old like other car manufacturers. On the other hand, especially in Germany, we have the very traditional OEMs, car manufacturers, who work in a way as an OEM, and they have their complete supply chain down to, I don't know how many levels they go down there. And because of that, they have these clear structured processes with all these qualifications, certifications, and it's for a startup, it's impossible to directly deliver something within, I don't know, 1 or 2 years to this type of OEM chain. Why? Because they have request times or project times of 5+ years. So even if the SOP is planned, you need to provide something for them 5 years before that or something like that. So this is not a time frame a startup could survive, to be very fair here. So this is something, if OEMs work together, those type of OEMs work together with startups more on the R&D side. That's totally fine. However, I think because this field of AI is now changing so fast, and we see, I mean, a frame of 5 years, everything is like has developed twice and 3 times, and we see a lot of new things popping up. And I think you cannot really cope with the speed of this development. This is not necessarily true for all the safety critical applications and the sensor types, but when you think of especially LLMs and user integration, either in the purchasing process or in the media devices, I mean, customers expect now a working speech to text model to enter the address, to ask questions, to do this, to do that. And I don't know how they will deal with this fast pace, but I think it's not working anymore like they are used to with this huge supply chain until SOP. So this is something which will definitely change. And yes, so I think that's also super interesting. But for my feeling is especially the young car companies, which understand them more as a tech company and a very user-centric approach and do a lot of software development on their own, they are faster than the traditional OEMs, especially in the electric vehicle area. But on the other hand, they don't have such a complex technical mechanical product. So it's always type of the company who are you're looking into.
No, loads of really, really interesting perspectives on there. This kind of links to one of the points we briefly discussed before we started the recording around ML model hosting, where the capability for training models should sit, and the risk of being reliant on a certain external provider for something that might be mission critical or differentiator. Would you mind just expanding on why this conversation is relevant and what your recommendations generally to organizations in the space are?
Yeah, so when it really comes to deployment of machine learning models, I mean, on the one hand, we have the automated autonomous driving parts, so there is no question asked. They need to be reliable and absolutely deterministic and run on embedded systems in the car, independent from any network connection. So that must just work because cars drive in area where they don't have connection, everything must be on there. Of course, there can be software updates and so on and so forth, but for the deployment of safety critical parts, they need to be in the car. We cannot have an internet connection. So when it comes to services, um, which are for the purchasing large language models, stuff which is not safety critical, or some nice user interactions on the display where you want an internet connection and go to your area. I would still recommend for the manufacturers to really be in charge of the deployment and the hosting of those models and not rely on any other third-party services here. Why? Because we see a lot of problems with hosted services. So really, when it comes to downtimes, you want an answer in kind of a real time. So if a user asks, you don't want to give an answer 10 minutes later. And that's what you can only ensure if you really own your deployment. Of course, you will have some kind of on-prem solution for that and some hybrid solutions where you go to the cloud. But I think it's super critical for a company, no matter in which field, to completely rely on a feature and the deployment from another company if this feature is really critical for the user experience. And that's why I think it's for deployment, it's so important to own it and know what you're doing there to provide all the KPIs you need in terms of real-time accessibility, downtimes, updates, and of course cost control, because these providers of AI services, at some point they increase the price of the tokens by the factor of 10. And if then your business model is still holding, this is a big question, but you're completely dependent on them. So this is definitely something you need to look into.
Yeah, it's really, really interesting point. I've heard lots of organizations that struggle with scaling use cases, because if you look at an economy like the US and you've got the same price for a token in the US compared to let's say India, for example, where the purchasing power, just comparing the two, is quite a bit lower. A use case might be completely viable in one region and not in the other. So definitely really important consideration, which also leads me to sort of regulation more widely, because not the greatest segue, but I guess where models are being hosted might be really relevant from a regulatory standpoint for certain organizations and use cases. And recently we've seen the introduction of the EU AI Act as one regulation that is becoming more important for many organizations. Specifically for your startup, Presada, what are the implications currently and maybe in the future as it relates to some of these legislative changes recently?
To be very honest with you, I mean, I came from the automotive area where we developed ASLD type of systems. So this is a regulated field, full stop. When we now talk in the area of startups and AI, especially in our use case, we are not safety critical. We provide a nice user experience, learning experience. For me, this AI Act is just kind of a supporting claim that we know what we are doing, so we don't mess up mess with your data, and we provide this trustworthiness as proof by certifications for our customers. Of course, it's always a lot of more work doing the certification process because everything is unclear now. We don't know exactly which documents we need to provide, what is allowed, what is not allowed. We will see a lot when these offices are really established in each of the member countries in the EU. But nevertheless, when you take now a look at the AI Act, what we see is, yes, we need to explain where the data from our models is coming from. We need to explain to the customer how we are doing it. And in terms of a very high level approach, so that customers can understand how their data is processed, how they are evaluated by us, what they get out. And everything what we now need to do is documented in the structured way for the AI Act. But that's something we already explain our customers beforehand, because for me, this is a big part of trustworthy AI. And especially in the DACH region, so Germany, Austria, and Switzerland, we see a very negative attitude towards AI. So we need to explain it anyways. So this is the only way how to tell the customers, okay, your data is safe, the evaluation is done on this and this and that. This is how everything works. Are you fine with it? The only thing which is now new is that we really need to mark the areas where we use AI so that it's really obvious for the customer. But I mean, that would have been visible anyways, because we play a little bit with avatars and question answering systems. So you see that you're not talking to a human. Now we put a label there. Okay, this is an AI. Are you aware of it? Yes or no? And that's what we really need to add. But I think overall, for such systems like we are providing, it's giving us um, additional trust from the customer side to have the certification. This is one thing in our area. Talking about say very safety critical systems, like in automotive, they fall in this high risk category. I mean, everything which is in there, this heavy documentation about the data sets, how the data is collected, biases, use cases, scenarios. This has already been done during the test process with the thousands of hours of kilometers, and each OEM should do anyways to have a clear understanding which scenarios are covered and which not. So I don't see there the big difference. It's additional work, additional effort, which means higher costs, yes. But for me, it's currently not the game changer or the game stopper for development.
I rarely speak to individuals that actually hands-on work on these processes. Would you mind giving a little bit of context to what the certification process looks like? You mentioned this really important aspect of classification there, which seems to be quite central. And then sort of a sub question to that. This element of explainability is one that this seems to be part of the process that some organizations have voiced concerns about, in terms of is this actually feasible and to what extent? Would you mind trying to demystify some of these
Sure.
elements?
So, I mean, when you now compare it again with automotive, where we have these different ASIL levels for different risk categories, depending if you develop a braking system or if you develop a media system which is not doing any harm. So you have different levels, and for each level you have stricter um, qualification aspects. That's what we know from automotive. With the AI Act, it's quite similar. So they have different categories depending on which use case, especially, and which type of technology you want to apply AI. You fall under one of four categories. The highest category is the prohibit category, which means it's completely forbidden to use AI there. For example, to classify people in the public area based on a camera image for their religion, race, age, something like that. So simply too dangerous to do that, so it's prohibited, full stop. The next things are much more interesting. So we have the high risk category. So there we have AI, which is applied um, in really dependable infrastructure like electronic grids, power supplies, something which is a critical infrastructure, or for example, also in automotive with safety critical applications where people could get harmed. But we also see it, for example, in areas where you wouldn't expect it, in education. For example, they say, okay, AI applied with automated ruling and judging about people's career paths. It's a really high risk. That's why automated recruiting tools, automated career path tools, they all fall into this high risk category. Then we have kind of, I think, high risk, low risk, and no risk. Yeah. Low risk categories, for example, chatbots. Yes, you can interact with the LLMs. People just need to be aware of, well, there is an AI talking to you and everything is fine. But as long as it's not one of the other use cases, you can use it, just need to mark it. And then there's this no risk category, for example, spam filters in your email program. Everyone is using a machine learning model there, but basically here you don't need to do anything. Talking about now the three categories of high risk and the more low risk areas, there you have, like in automotive, different qualification steps. You need to provide these documents, and what we will see in future is in every member state you will have an office where you need to hand in those documents which get checked. But how this exact process is something we will see next year, because I think none of the offices in any member state has been really open and operating so far. But I'm just aware of the areas in Germany and Austria, so I don't know how it's about the other states. That's what we will see there. What we currently do to prepare ourselves, of course, we are getting in contact with lawyers being specialized in this area, and also the area of data protection. So to discuss with them, okay, based on your judgment, would we fall into the high risk category? Would we fall into the lower risk or mid risk category? What do you think? And especially which features are high risk? And if we don't implement them, if we change the way how we use the sensor data, would this make any difference? And that's how we now approach it as a startup. But as I said, because we have such a negative attitude towards AI in Germany, in Austria, we need to explain our systems in any ways to the people and to our customers. So this is something which is falling into this line of explainability for us.
On that last point, is this like realistic just from sort of an outside perspective? Loads of these LLM solutions seem to be a little bit of a black box. I mean, just thinking of ChatGPT, we've got basically all of these sort of possible data out there that that we can access and through the internet, that's being used to essentially, or has been used to train the models, and just given the sort of inherent nature of the solution, something that's generative and that's improving itself over time, it's changing over time. How would you explain to someone who doesn't work on these technologies how you can ensure that you actually explain in a reliable and clear way what is happening in these models?
Yeah, that for the big LLM models, this will be a real challenge. So these answers for the certification must be they must be provided from the vendors. So like OpenAI, they need to really be transparent about on which data they trained. When we think about more our use case, I mean, we know what data we refine the models on, what we use as base, where is this coming from. So this is, for us, it's easier in these terms. So that's why, again, this own your deployment, own your models is playing into our hands here. But it will be super tough in high risk categories. Let's think of recruiting tools in HR and judgments about career paths. If you don't know on which data this type of LLMs got trained, and I think, at least from how I read now this approaches, all the startups which just implement OpenAI APIs and are not well aware of what's going on there in the background, they might have a problem if they fall into this category. Maybe they can restrict the use cases, play around with different options to also visualize it. But I think that might be really, really challenging if you apply a pre-trained black box API in these areas. I don't know how this will work, but in my opinion and how I read this document so far is that the vendors and the providers of those models need to provide information about their data sets. Otherwise, they cannot be used in these areas.
One final question from my side. Imagine that you're talking to the chief data and AI officer at one of the incumbent automotive manufacturers, assuming that's a role that has been established. What would be your top 3 recommendations to unlock the most value from their AI in a sustainable way?
Ooh, that's a broad question. That's a very broad question. To be very honest, depending on the product, I see currently the biggest value and the fastest wins in the direct user interaction. So when we're talking about customer support, when we talk about purchasing support, or also the interaction and the media devices in the cars. So really where the user gets in touch with the experience car. There we can see quick wins because they're also not safety critical and they can be easily applied with updates. Whereas all the things I mentioned about the embedded software, the embedded systems, I mean, this needs to be something planned up for the next 5 years probably. But especially there where we have this user interaction, we can get really good and fast wins out.
Brilliant. Thank you so much for your time today, Julia. That's been a real pleasure.
Thank you. Thanks for the discussion.